Hello pre-calc folks. Today I want to just go over some of our classwork, so I'm going to do this rather quickly. And so we have 4 problems that we were working on in class, and on the first one we wanted to add fractions and simplify. So in doing so, we were working with the left side. And we have to have the same denominator, so I'm just going to make the 2 fractions have the same denominator. And remember, whatever we put in the bottom in the denominator, we have to put in the numerator to maintain, to make sure that that fraction stays equal. So this had a cosine of a in the numerator, and it had the 1 plus sine of a. So I'm just going to add or multiply it by 1 minus sine of a in the numerator, and on the other side I'm going to use the other term as a multiplier because I'm putting a 1 plus sine of a in the denominator. We have one great big denominator now. It's just going to be 1 minus sine of a, 1 plus sine of a, all over. Now we have to multiply this out, and this is a big mistake I saw a lot of kids making, was they were not distributing cosine of a to both of these terms. So I'm going to write that out, showing that. So cosine of a minus cosine of a times sine of a, plus, again, distribute cosine of a plus cosine of a sine of a. And now you just simplify what is in the numerator. In the numerator it becomes 2 cosine of a, and these terms cancel because they're opposites, all over, and I'm going to FOIL the denominator, and I'm going to have 1 minus sine squared of a. And from this you should notice that the denominator is an identity. So we have cosine squared of a, which will result in what we're looking for, 2 over cosine of a, because this term would cancel with that term. I'm just going to write in the reasons later on, so you can see what we did to each term. So I'm just going to pause the video so I don't bore you to death with it, and then we'll move on to the next problem. So I've just written in the reasons, and you can see here we added fractions, we multiply the numerator. Well, we multiply numerators. We basically just added the fractions and we multiplied the numerator terms by distributing. Then we simplify the numerator, then we FOIL the denominator, and then we have our Pythagorean identity, which resulted in the switch from 1 minus sine squared to just cosine squared, and we use the division property. Now on number 5, I think I asked the class to do conjugate multiplication on the right hand side. So we're going to work with the right. I have cotangent squared of beta, and the denominator is cosecant of beta plus 1. And I'm going to multiply top and bottom by the conjugate. And when I do that, I get cotangent squared of beta times cosecant of beta minus 1 all over. Now remember, we use a conjugate because what it does is it makes the denominator just be the first and last term, first minus the last term, difference of squares. And at this point, hopefully you recognized that we have, let me just write out the numerator. The denominator is going to be the cotangent squared of beta. And I have to make sure I copy down the last step properly because that was supposed to be squared. So what you end up seeing is that by division property, this cancels with this, and we have arrived at what our goal was to get it to be, was to prove that the right hand side equals cosecant of beta minus 1. I'll write in the reasons. Conjugate multiplication for the first step. Second step, FOIL the denominator. Third step, we recognized Pythagorean identity. The last step was division cancellation. Moving on to the next one. I believe on the next one we said we were also going to work on the right hand side, and we were going to use we were going to do an identity substitution. So I'll just start off with just the right hand side. We had secant of x minus cosine of x. I was going to do an identity substitution. So most everybody got this, except that's a minus sign. And then when we find the common denominator between both, it's just cosine of x. But I have to adjust the numerator of the second term by multiplying it by cosine again, so that becomes cosine squared of x. You can now add your fractions. Recognize that you have a a misprint there because I miswrote the bottom. It should be just cosine of x. Recognize that the numerator is sine squared of x from Pythagorean identity, and that's over cosine of x. Make a little bit of room, and then we can say that you can rewrite sine of x squared, or sine squared of x I should say, as sine of x times sine of x over cosine of x, which turns into sine of x over cosine of x times the sine of x over 1, which is the tangent times the sine. And that's what, if we zoom out a little bit, that's what we were trying to prove the identity was going to become. We can write our reasons. Our reasons would be reciprocal identity substitution, adding fractions, Pythagorean identity, which is here, and then using a reciprocal, well actually this is, we just split up our sine squared and then use the reciprocal identity. Our last problem, just to make sure everybody understands this problem, that should be an equal sign in the middle. So we have secant of x, cosecant of x. Prove that that equals tan of x plus cotan of x. So again, we're going to use a substitution on the right side, and we're going to replace tangent and cotangent with sines and cosines. So tangent is sine over cosine. Cotangent is cosine of x over sine of x. We find the common denominator, which is going to be sine of x, cosine of x for both. We adjust our numerator. Now in blue I'll keep it what it was, or what was in the numerator, but in red I'll put what wasn't there before. So in this one we have to put another sine of x there because it just had a cosine before, and in this one on the right I'm going to put a cosine of x in the numerator because it wasn't there before. So whatever I put in the denominator, I have to put in the numerator. So now I can add these fractions. I have sine squared of x plus cosine squared of x all over sine of x cos of x. Using our Pythagorean identity, we have 1 over sine of x cosine of x, which can turn into, well, let me just take a look and see what I'm looking to make it or prove that it's equal to secant of x cosecant of x. So I can rewrite this as 1 over sine of x times 1 over cosine of x. I'm just splitting apart a fraction that has multiplication between the two, and then this would turn into cosecant of x times secant of x, and that's what they were looking for us to prove. So just to go back and go through the steps, the first part we used this time quotient identities. Then we used then we added fractions, common denominators and such. Then we when we combine the numerator, we saw that we had a Pythagorean identity. And lastly, we separated the multiplied fractions and we arrived at our identity by using quotient, reciprocal identities. I hope this is helpful. Please watch this before class on Monday so that we can get right into business for doing the other identities for Monday class period. Have a good weekend. Bye now.